Welcome to a deep dive into, well, the truly cutting-edge world of advanced underwater sensing. Today, we're putting the ISA 200 and ISA 500 altimeters from Impact Subsea under the microscope.
Yeah, these aren't just any sensors.
No, they promise really unparalleled perception beneath the waves, and we're here to unpack exactly how they do it.
Our mission really is to show you why these devices are such a game changer. We're talking precision, reliability.
In the toughest environments, too.
Exactly. In the most unforgiving parts of the ocean. We're looking at tech that tackles the real challenges of working deep underwater, bringing a whole new level of clarity.
Okay, so let's dive into their capability first. These are sonar-based devices, right? Using sound to measure distance.
That's right.
And the ISA 200, it can range over 250 meters. That's what, about 820 feet?
Yeah, impressive range. And the ISA 500 goes beyond 120 meters, so 393 feet.
But what really gets me is how the environment itself changes that range. It's not fixed.
It's true. And it makes sense when you think about it. What the sonar is actually pinging off makes a huge difference.
Like what?
Well, think about a solid, reflective target, like rock. That can give you a much greater distance reading, sometimes over 175 meters for the ISA 500.
Okay.
But if you're aiming at something softer, maybe marine growth or sediment plumes.
Much fuzzier target.
Exactly. That range might drop to 80 meters, maybe even less. The clever part here is how these altimeters actually optimize their sensitivity.
They adjust.
They adjust, yeah, to give you the best possible reading, whatever conditions you're facing down there.
That's incredible, but how do they maintain any kind of precision with all that variability? I mean, this is where it gets truly mind-blowing for me. These sensors boast an astounding 1 millimeter accuracy and repeatability. 1 millimeter, that's tiny.
It is. Barely the thickness of a credit card, like you said.
So how? How do they achieve that kind of pinpoint precision through water, which can be so murky and unpredictable?
It's a fantastic question. And it's down to a really advanced digital correlation technique. Imagine trying to pick out a tiny, clear radio signal in a storm of static. This technique is like a super advanced filter.
Right.
It rapidly sifts through literally millions of echoes, actually 2 million times per second, to find the true signal, ignoring the noise.
2 million times a second. Wow.
Yeah, and this isn't just about resolution, which lots of sensors talk about.
What's the difference there?
Well, resolution just tells you the smallest change it can detect. Accuracy tells you how close that measurement is to the actual real-world distance.
I see. So it's not just detecting tiny changes, it's knowing those changes are correct.
Precisely. The ISA 200 and 500 deliver both. And that's absolutely critical for jobs that used to need much more complex, often fragile laser systems.
Like what kind of jobs?
Things like detailed pipeline surveys, or maybe precisely docking an ROV with subsea equipment. Tasks where being off by even a little bit matters a lot. This is a huge leap in underwater reliability.
Okay, so the sensor's incredibly precise, but how do you know the data itself is trustworthy? Especially if the water's murky or full of particles?
All right, good point. That's where their correlation factor comes in. Think of it like a built-in quality check, a confidence score for each echo.
A confidence score?
Yeah. If the sensor isn't at least, say, 50% confident that an echo is a genuine reflection, if it's below a 0.5 correlation, it just ignores it.
So it filters out the dodgy readings automatically.
Exactly. You're only getting data that the system itself considers reliable. Every reading you get is one you can trust.
That's brilliant. Intelligent data right out of the box. But how adaptable are they if you're in a busy subsea area with other acoustic gear, maybe?
Yeah, that's key. Their adaptability is fantastic. The ISA 500, for instance, lets you actually adjust its operating frequency.
Oh, okay.
Anywhere between 400 and 600 kilohertz. So you can actively steer clear of interference from other sensors.
Smart.
And what's more, pretty much all their settings are fully software configurable through CView. You can tweak detection modes, maybe use strongest detection if you're navigating through suspended sediment, or you can even use a multi-echo capability for tracking several targets at once. It's like having a Swiss Army knife for underwater sensing.
And it gets even more visual, doesn't it? There's an optional echogram feature.
That's right. That essentially turns them into single-beam imaging sonars.
Imaging sonars, wow.
Yeah, it visualizes the whole water column and the seabed below. You get up to 2,000 data samples per ping, giving you a real-time picture. Really helps with visual ID of what's down there.
Okay, that's impressive. What about vehicle movement? If the ROV or AUV is tilted?
Yes, slant range. A standard altimeter might just give you the distance along that tilted path.
Which isn't your actual height off the bottom.
Exactly. But with the optional built-in AHRS, That's an attitude and heading reference system.
Like in drones.
Sort of, yeah. It constantly knows the vehicle's pitch and roll. It does the trigonometry internally to correct that slant range and give you the true vertical altitude.
So you always know your actual height, regardless of tilt.
Precisely. Very clever.
So, okay, incredible intelligence, pinpoint precision, but underwater gear takes a beating. How tough are these things? How are they engineered for endurance?
Well, they're built for it. Seriously tough.
Yeah.
Construction is from titanium or acetyl, very durable materials.
And the depth ratings.
The ISA 500 is rated up to an incredible 11,000 meters.
11,000, that's
Yeah.
deeper than Everest is tall.
That's Mariana Trench territory,
Yeah.
literally capable of reaching the deepest parts of our oceans.
Wow.
And it's not just about pressure, they're rigorously tested to API 17F standards for shock and vibration.
Which means?
It means they're basically put through hell in testing. Extreme shocks, crazy vibrations, way beyond normal operational use, so you can absolutely trust they won't fail when it matters most, thousands of meters down.
Okay, so we've really covered a lot. Incredible range, that pinpoint 1mm accuracy, intelligent data quality, all wrapped up in a design that's robust and amazingly adaptable.
Yeah, what stands out, I think, is just the meticulous engineering. It brings real insight, genuine reliability to the underwater world. It transforms what's actually possible in these really challenging environments.
So wrapping this up, what does this all mean for you? When every single millimeter counts, how might these kinds of precise, reliable eyes continue to shape how we understand and how we interact with our planet's last unexplored frontiers? What new possibilities open up down there?